find the area of triangle QRS if the quadrilateral PQRS is a parallelogram and angle PQR is twice the size of angle QPR. So we are asked to find the area of this triangle here, triangle QRS. And they said this here PQRS is a parallelogram, meaning this line here is parallel and equal to this line, and also this line here also parallel and equal to this line. Here, this angle PQR is twice the size of this angle QPR. So since this is 2x, this must be equal to 2 times 2x, which equals to 4x. And we can see here, this side here, PR is 9 centimeters in length. So how can we find the area of triangle QRS? The mathematical formula for finding the area of a triangle is half base times height. But what are the base and the height? To know the base and the height, we need to know what type of triangle QRS is. And for that, we need the length of the sides and most importantly the sizes of its angles. Though we don't have any, but based on the information given here, we can try finding the length and the size of the angles of triangle QRS. So since this quadrilateral here, PQRS is a parallelogram, and this side here is 9 centimeters in length, this line must also be 9 centimeters because opposite sides of a parallelogram are parallel and equal. Here is another thing to be noted. Since this angle here is 2x, this here must also be 2x because opposite angles of a parallelogram are equal. Here also, if you look, since this line and this line are parallel to each other, and this line QR is a straight line intersecting both, that means this angle here and this angle here are alternating angles. And we all know that alternating angles are equal, and hence this also 4x. So now, if you look, this angle here, 5x, and this 4x here are lying on the same straight line. And we know that the sum of angles on a straight line is 180 degrees. So to find the size of each angle, we need to find x. And to find x, we can form an equation that 4x plus 5x equal to 180 degrees. 4x plus 5x is 9x. So 9x equal to 180 degrees. To find the exact value of x, we divide both sides by 9. So 9x over 9 equal to 180 over 9. Here 9 cancels 9. And here 180 degrees divided by 9 is 20 degrees. So x equal to 20 degrees. Substituting x equal to 20 degrees here, this here 5x equal to 5 times 20 degrees, which equals to 100 degrees. Here 4x is 4 times 20, which is 80 degrees. And here 2x is 2 times 20 degrees, which is 40 degrees. So since this is 80 degrees and this is 40 degrees, this must be equal to 180 degrees minus 80 degrees minus 40 degrees, because the sum of angles in a triangle is equal to 180 degrees. 180 degrees minus 80 degrees minus 40 degrees is 60 degrees. So this angle here equal to 60 degrees. Now we can see that none of the angles of the triangle are equal, and that implies that the triangle is a scaling triangle. So we can take any possible side as the base. So let's take this line QS here as the base. So now the base of the triangle is 9 centimeters in length. But what is the height? Since we have the size of all the angles of the triangle, if we have the length of this side or this side here, we can use the SOHCAHTOA tool to find the height of the triangle, because this here is a right angle, but we don't have the length of any. But since we have the length of this line here from this triangle, we can use the sine rule to find the length of the two other sides. So let's find the length of this side here. So using the sine rule, 9 over sine 80 degrees equal to line QR over sine 40 degrees. Making line QR the subject, line QR equal to 9 over sine 80 degree times sine 40 degree. Press your calculator. 9 over sine 80 degree multiplied by sine 40 degree is 5.8743. So this line here is 5.8743. Now, since we have this side here to be 5.8743 centimeters, we can use the SOHCAHTOA tool from this triangle here to find the height of triangle QRS. So from this angle here, 60 degree, this here is opposite because it's facing angle 60 degree. This here the hypotenuse because it's facing the right angle, and this here the adjacent. So the adjacent is not related to what we are finding, we just ignore it. So here the opposite, O is involved, and here hypotenuse H is involved. So what part of the SOHCAHTOA tool contains O and H? This here SOH contains O and H. So SOH means sine theta equal to opposite over hypotenuse. Theta is 60 degree, opposite is the height, and hypotenuse is 5.8743. So sine 60 degree equal to height over 5.8743. Making height the subject of the formula, height equal to sine 60 degree times 5.8743. Sine 60 degree times 5.8743 is 5.0873. So now height equal to 5.0873. Now we found the height of triangle QRS to be equal to 5.0873, and we have the base here to be 9 centimeters. So substituting it into this equation here, find the area, half base times height equal to 1 over 2 open brackets 9 times 5.0873. So area equal to 1 over 2 open bracket 9 times 5.0873, which equals to 22.8929. We can round it off to be equal to 22.9. So the area is 22.9 centimeters square. So we found the area of triangle QRS to approximately be equal to 22.9 centimeters square. Find the area of this triangle BDE if this angle here ACD is a right angle. So from this now, this triangle ACD is a right angle triangle, and also triangle BCD here, but we are asked to find the area of this triangle BDE here. So how can you find the area? The general formula for the area of a triangle is half base times height, but what are the base and the height of a triangle? To know the base and the height of triangle BDE, we must know the length of its sides, and most importantly, the angles of the triangle. So what are the length and the angles of the triangle? That's what we are going to find now. Since this triangle BCD here is a right angle triangle, and we have the length of this side here as 3.5 centimeters, and this here 2 centimeters, we can use the Pythagorean theorem to find the length of this side here. The Pythagorean theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the two other sides. Hypotenuse is the side facing the right angle, so this line BD here is the hypotenuse. So using the Pythagorean theorem, hypotenuse square equal to 2 square plus 3.5 square. 2 square is 4, 3.5 squared is 12.25, 4 plus 12.25 is 16.25. So hypotenuse square equal to 16.25. To find the exact value of the hypotenuse, we find the square root of both sides. So square root of hypotenuse square is equal to square root of 16.25. Here square cancels square root, and here square root of 16.25 is 4.03, which approximately equal to 4. So we'll find the length of this side here to be 4 centimeters in length. Now to find the other sides, we need the sides of the angles of the triangle. So still from this triangle here, since we have the length of all the sides, we can use the so-called tool to find the sides of this angle here. So from this angle here, this is the opposite because it's facing the angle in question. This here the adjacent, and this is the hypotenuse because it's facing the right angle. So from this here, cos theta equal to adjacent over hypotenuse. Theta is this angle here, adjacent is 2 centimeters and hypotenuse is 4 centimeters. So now cos theta equal to 2 over 4. 2 over 4 is 0.5. So cos theta equal to 0.5. To find the exact value of theta, we'll find the cos inverse of 0.5. So theta equal to cos inverse of 0.5 now. Cos inverse of 0.5, press your calculator, is 60 degrees. So theta equal to 60 degrees. We found the size of this here to be 60 degrees. So since this is 60 degrees, this here 90 degrees, and this 2x, to find the size of the other unknown angles, we need the value of x. So to find x, we can form an equation here that 60 plus 90 plus 2x equal to 180 degrees, because the sum of angles in a triangle is equal to 180 degrees. 60 plus 90 is 150. So 150 degrees plus 2x now equal to 180. If we subtract 150 degrees from both sides, 2x equal to 180 degrees minus 150 degrees. 180 degrees minus 150 degrees is 30 degrees. So 2x equal to 30 degrees. From here, since 2x equal to 30 degrees, we can substitute 30 degrees directly here and also here. But to find this, we must find the exact value of x. So back here, to find x, we divide both sides by 2. So 2x over 2 equals 30 degrees over 2. Here, 2 cancels 2. And here, 30 degrees over 2 is 15 degrees. Now x equal to 15 degrees. Substituting x equal to 15 degrees here, 3x will be equal to 3 times 15 degrees, which is 45 degrees. And if you look here, since this is 30 degrees and this is 60 degrees, this must be equal to 180 degrees minus 30 degrees minus 60 degrees, because the sum of angles in a straight line is 180 degrees. 180 degrees minus 30 degrees minus 60 degrees is 90 degrees. So that means this triangle BDE here is a right angle triangle. And in a right angle triangle, when finding its area, any of the two sides that are perpendicular to each other can be the base or the height. So that means this line BE here can be the base, and if this is the base, this must be the height, because they are the two sides that are perpendicular to each other. And we have this as 4 centimeters, so that means the height is 4 centimeters. But what is the base? Since triangle BDE is a right angle triangle, and we have the length of this side here as 4 centimeters, if we have the size of any of these two angles here, we can use the so-called tool to find the length of this side here. But what are the size of the angles? From this triangle here, since this is 45 degrees, this here 90 degrees, and this 30 degrees, we can label this P and form an equation 45 plus 90 plus 30 plus P equal to 180 degrees, because the sum of angles in the triangle is equal to 180 degrees. 45 plus 90 degrees plus 30 degrees is 165 degrees. So 165 plus P equal to 180 degrees. Subtracting 165 degrees from both sides, now P equal to 180 degrees minus 165, which equals to 15 degrees. So that means this angle here is 15 degrees. So coming back to this triangle here, to find this side here, we can use a so-called tool. So from this angle here, this is the opposite because it's facing angle 15 degrees, and this here the adjacent. So here tan theta equal to opposite over adjacent. Theta is 15 degree. Opposite is line BE and adjacent is 4. So tan 15 degree equal to line BE over 4. Making line BE the subject of the formula, line BE equal to tan 15 degree times 4. Tan 15 degree times 4 is 1.07. So line BE equal to 1.07 centimeters. We found the length of line BE to be equal to 1.07 centimeters. Now recall we have line BE as the base of triangle BDE. So that means the base is 1.07 centimeters. And here we have the height as 4 centimeters. So substituting it into this equation here, half base times height will be equal to 1 over 2 times 1.07 times 4. 1 over 2 times 1.07 times 4 is 2.14. So we found the area of triangle BDE to be equal to 2.14 centimeters squared.